Hi, this is Mrs. Bolin with the University of West Florida, College Algebra, Section 5.7 lecture. Coming in, getting ready for our up-and-coming exam. So this is the last lecture that has to do with preparation for Tuesday's exam. So let's get started. We're going to be talking about inverse functions. Okay, so in inverse functions, the functions f and g are inverse functions if the pair AB, the coordinates AB, satisfies y equals f of x, and then the pair BA satisfies the function y equals g of x, okay? And if f and g are also inverses, if the composite of f composed with g equals x and g composed with f equals x. So that would be f composed with g, g composed with f. They both have to equal x, okay? So when either one of these statements are true, then we have what's called an inverse. So we use this notation right here to denote the inverse function. It's read the inverse of f of x. Excuse me, it's been a long day. It's read the inverse of x in the inverse function, and it is not denoted. Okay, this is not an exponential. It does not mean that that goes in the denominator. It doesn't mean the reciprocal or anything of that nature. It is simply the notation that is used to denote that this is an inverse function. So a function has an inverse if the function is one-to-one. Remember, that's the definition of a one-to-one. It means that the original function, the original equation is a function, and then the inverse equation is also a function. That's what a one-to-one is. And recall that for a relation to be a function, we need for each x only one y. Okay, so for each x only one y. And then for the function to be one-to-one, we also need for each y to only have one x. So that's important qualifications there. We can determine if a function is a one-to-one graphically by using the horizontal line test. Each horizontal line can only intersect the graph once. Okay, so don't forget we have the vertical test, which determines whether or not the function is, or the equation is a function. The horizontal test is used to determine if a function is a one-to-one function. Okay, so example 1. It says determine if the function defined by the set of ordered pairs has an inverse. If so, find the inverse. So remember, we look just to find out to begin with, if it is a function, we look to see whether or not each x maps to exactly one y. Well, I only have one x listed. I have a 2, a 3, a 4, and a 5. I don't have any duplicates. So it is a function because each x maps to exactly one y. But now it said determine if it has an inverse, which would mean it's a one-to-one. Now we need to look at the y values and see, do we have any duplicate y values? We have an 11, a 10, a 9, and an 8. All unique. Okay, so yes, this is a one-to-one function because each x maps to exactly one y and each y maps to exactly one x. So I was going to handwrite that, but you know, I am a faster typer, so let's just see if I can, I don't know if I can put a thing on here. Oh, I can right here. So yes, this is a one-to-one function because each y maps to exactly one x. Okay, and it says if it is a one-to-one and it does have an inverse, find the inverse. So here we go. So the inverse is going to be, so the inverse is going to be, we're going to swap the order around. So we have 8, 2, Swap the x and the y around. So now I have a 9, 3. Swap the x and y. So I have a 10, 4. Swap your x and your y. 11, 5. And so our last one is 11, 5, and that completes the inverse. Okay, now we want to look at the next one. So the first question, is this a function to begin with? So I have a 4, 6, 10, 3. Because I have all unique x's, I know that yes, it is a function. So yes, it is a function. The question becomes is it a one-to-one function? If it's a one-to-one, then we have an inverse, right? So I have a 7, a 14, a 2, and a 7. So I have 2 7s right here and right here. The question is do they map to the same number or different numbers? And as you can see, they map to different numbers. One maps to 3, the other maps to a 4. So even though, yes, this is a function, it is not a one-to-one function. Because 7 maps to both 3 and 4. Thus, we have two different outputs for one input. Okay, so it is not a one-to-one function. Okay, given the graph of f of x, determine if it is a one-to-one function. So the test for a one-to-one function is what's called a horizontal test. And if you can draw a line through and you can have more than one spot where it intersects, it is not a function. So because I can draw a line through right here, a horizontal line, and it intersects at 2 different spots, it is not a one-to-one function. So not a one-to-one function. Let's look at the next one over here. I can draw a lot of horizontal lines and they're all going to only intersect one time. So yes, this is a one-to-one function. Alrighty. It says use the given graph of f to find the following values of the inverse. So to do this, we're going to look here at A to begin with, and it says find the inverse when x equals -4. So because we're working with the inverse, we're going to be looking at this graph, and we're going to start here, and we're going to come down to y equals -4, okay, because we're doing the inverse. So when y equals -4, normally that would be x, but we're dealing with the inverse, so we're going to look at y. Now we back it out to find out what is x. And x, you can see, is -2. So here, for the inverse, the answer is -2. Now this one here again, we do the opposite of what you would normally think of because we're dealing with the inverse. So at -2, we're going to find -2 right here on the graph. And now we're going to go over and find the x value where it meets. And you can see that the x that corresponds with y being -2 is a +2. Next one is going to be -1. So we're going to come in here to -1, and we're going to come all the way over here, and we're going to see that this is equal to 7. So we're working this backwards. Okay, so we have 4 steps here for finding the inverse function. You're going to notice that your notes does not have the step 0 on it, but it is really the very first step that we have when we're looking for the inverse. Okay, so add that onto your notes, and then also make sure you remember that when we're actually working and solving for the inverse function. So step 1, we're going to replace f of x with y. Step 2, we're going to switch x and y, or interchange them. Step 2 is going to be solve for y. Step 3 is replace y by the inverse notation. So ideally this should be number 1, 2, 3, 4. Okay, but since we didn't have the other on there, I had to start with number 0. Or I guess I could have started with 0.5 or something goofy. Okay, so find the inverse function of f of x is equal to 6x minus 2, and then find the value when x equals 10. So here we go. Step 0 says replace f of x with y. So I'm given f of x there, so I'm going to write y is equal to 6x minus 2. Okay? Step 1, switch x and y, interchange them, swap them out. So where there's a y, you put an x, and where there's an x, you put a y. So I end up with x is equal to 6y minus 2. The next step says solve for y. So if I have x is equal to 6y minus 2, I'm going to solve for y. I'm going to add 2 to both sides. I get x plus 2 is equal to 6y. I'm going to divide both sides through by 6, and I'm going to get y is equal to x plus 2 divided by 6. Okay? And then the last step says replace y with the inverse notation. So take our y and replace it with the inverse notation, which says the inverse of x is equal to, and then you put in this expression right here, x plus 2 divided by 6. Now we just found the inverse of f of x. Okay? The next thing we want to do is find the inverse, evaluate it for the number 10. So here we go. So part B is finding this. So literally we're just going to plug in 10 right up in here. So this is going to be 10 plus 2 divided by 6, 12 divided by 6, which equals 2. So the inverse of the function evaluated at 10 is equal to 2. And there's the answer. Okay, here we go. Next one. Again, it says find the inverse, then find it evaluated at a particular point. So here we go. Step 0 is replace f of x with y. So we're going to end up with y is equal to 4 divided by x plus 2. The next step, switch your x and y. So if it's a y, it turns into an x. If it's an x, it turns into a y. The next step, solve for y. So I have x is equal to 4 times y plus 2. If I'm going to solve for y, I'm going to need to get rid of my that y, that's a y right there. Let me erase that and turn that into a proper y. There we go. So I need to get that y out of the denominator, and I need to remove that all the way over. So what I'm going to do is I'm going to multiply both sides through by y plus 2. Because what I do to one side, I must do to the other side. And then you're going to notice that on this side, it factors away. Okay? It reduces right on out. So I end up over here, I have y plus 2 times x is now equal to 4. I'm going to distribute my x to both the y and the 2. So I end up with, multiplying it to both, xy plus 2x is equal to 4. My objective is to solve for y, so I need to get my 2x over. And I get xy is equal to 4 minus 2x. And now I'm going to divide both sides through by x. Let me move this up just a little bit. There we go. What I do to one side, I do to the other side, and those disappear. I factor right on out. And I get, therefore, y is equal to 4 minus 2x divided by x, which is also, I can swap the numerator around so I have my x's in the lead. So it's going to be minus 2x plus 4 divided by x. Okay, I'm not quite done. I have one more step. Remember, I have to replace my y notation with the inverse notation. So I'll do that right up here, and I'll say step 3 is that f, the inverse of x, is going to be equal to negative 2 x plus 4 divided by x. I just want to make sure I got that down right. I did. Okay, so right here is the inverse. Now I have one more thing I have to do. I need to evaluate the inverse at negative 3. So literally what we're going to do is we're just going to plug in negative 3. So we're going to say the inverse at negative 3 is going to be equal to negative 2, substitute in negative 3, plus 4 divided by negative 3. So that's going to be our substitution. So negative times a negative is going to give me a positive. It's going to be 2 times 3, so that's a positive 6. Positive 6 plus 4 is 10, divided by negative 3. And so that's going to be negative 10 thirds. We have a couple more problems and then we're done for the lecture. It's a fairly short lecture today, which is nice. Okay, again, find the inverse. So I'm going to do this one, and then I'm going to let you do number 7 and on your own and see if you get it right. We'll work together on it, though. You know, I will present the material. Okay, step 0 on this one here is we take and we say that we must replace f of x with y. So it's going to be y is equal to 2x divided by, come on computer, 5x minus 3. 5x minus 3. Okay. Step number 1. We're going to swap out our x's and y's. So I end up with x is equal to 2y divided by 5y minus 3. The next one, I'm going to write it up here because I need room to work, is I solve for y. So I'm just going to rewrite the problem as it is right now, if I can get my computer to keep everything. So the first thing I want to do is multiply both sides through by 5y minus 3. 5y minus 3. And when I do that, over here, that factors away, that cancels out, and so over here I'm left with 5y minus 3 times x is equal to 2y. Now I'm going to distribute my x to both terms in here, and so I end up with 5xy minus 3x is equal to 2y. Again, my objective is to solve for y, which means I want to get all my y's on one side and everything else on the other side of the equal sign. So I'm going to actually bring my 2y over here and my 3x over here. So it means I'm going to add 3x to this side, and what I do to one side, I do to the other. I'm going to subtract 2y from this side, and I'm going to subtract it from this side and add straight down. So I get 5xy minus 2y is equal to 3x. So far, so good. Now notice I have a y that's common to both terms over here on the left-hand side, so I can factor out my y. And I'm going to do that right up here. So I'm going to factor out a y, so that means I have y times 5x minus 2 is equal to 3x. Now my y is connected to the 5x minus 2 through multiplication, so I can use division to separate them. So what I do to one side, I do to the other side. Those cross out, and I have, therefore, y is equal to 3x divided by 5x minus 2. My last step, step number 3, is I use the inverse notation to say that the inverse of x, or of the function, is 3 of x divided by 5x minus 2. And that is the answer right there. Okay? So what we're going to do is I'm going to pause. I'm not going to pause. I'm just going to delay here for a moment and let you hit the pause button and let you solve this all the way through, and then push play to see if you got it right. I'll see you back in a moment or two. Okay, welcome back. Here's the answer right over here. How'd you do? If you got the right answer, I want you to take and send me the code word sunflower. Okay, the code word is sunflower, and that will let me know that you did this work and you actually got it right. If you did it, but you made a mistake, no matter how small it was, if you didn't get it 100% correct, I want you instead to send me the code word banana pepper. Okay, so, or just pepper if you want. Okay, those are your code words. That lets me know that, one, you attempted it, and whether you got it right or you got it wrong. Okay, and hopefully I will get at least a word from each student in the class, which tells me then that everybody watched this video. Let's go over this real quick in case you didn't. So, step 0, we replace the f of x with y. That's the only thing that I did here. This right here is identical to this over here. The next step, I swap all my y's with x's and all my x's with y's. The next step, I'm going to solve for y. So I rewrote down the original equation that I had right here, and I said, I have a y minus 4 right here. I need to get rid of that out of the denominator. So if I multiply both sides through by y minus 4, and what I have left then is this right up here. And I just rewrote this right here, and then I only wrote what I had left after the simplification right here. Alrighty, now the next thing I did is I distributed my x to both terms, and I just copied this right on down. And I said, I have a y over here and a y over here. I need them on the same side, so I'm going to bring my y that's on the right hand side to the left. And then I add it straight down. So I had xy minus y minus 4x is equal to what I had left on the right hand side, which was 5. And I said, oh, I can move this over to the right. So I added 4x to both sides. So I ended up with xy minus y is equal to 4x plus 5. Again, solving for y. I had a y as a common factor here of both terms, so I factored it out, and what I had left then was an x minus 1. And since this was attached through multiplication, I divide it to get the y by itself, and what I did to one side, I had to divide on the other side. And so I ended up with y is equal to 4x plus 5 divided by x minus 1. And then I had to substitute in the proper notation. Alrighty, so again, sunflower if you got it right, and banana pepper or just pepper if you made a mistake. This is our last question for the day, so we're going to do the same thing. I want you to at least try it right now on your own. Hit pause, and when you come back, you can check then to see if you got it right or if you got it wrong. I'll see you back in just a moment. Okay, welcome back. Right here is your final answer. How did you do? Did you get it right? Boy, I hope that you got it right. If you did, I want you to send me the code word DOG, D-O-G. And if you got it wrong, even a slight mistake, but you tried it, I want you to send me the code word CAT, C-A-T. All right, so let's walk through this. We have step 1, replace the f of x with y. Step 2, if it's a y here, it becomes an x down here. If it's an x up here, it becomes a y down here. The next step is solve for y. So in order to do that, all I did initially was just rewrite in green what I had right over here. And then I said, ooh, I've got a cubed right there. To get rid of it, I'm going to have to cube each side, okay? So I did that, and when I do that, this becomes x cubed, and this right here removes the radical, so all I have left is y minus 7. That's because that's to the cubed root, and then I cubed it. So it becomes y minus 7. My objective is to solve for y. So in that case, I added 7 to both sides, because what I do to one side, I do to the other. And then I add it straight down, and I got x to the cubed to the third power plus 7 is equal to y. And now I have y is equal to something, so all I have to do is swap out my notation for the inverse notation that says the inverse of x is now equal to x cubed plus y. And that is it for this lecture. I hope you enjoyed it. I hope you learned the material. And if you have questions, let me know. Keep an eye out for information on the exam and how that's going to work a little bit more in detail over the weekend. I will see you soon, and study hard. Text me if you have any questions. Again, my cell number is 850-376-4307. If you need to reach me, just send me a text. I'll talk to you later. Bye.